What if your CCTV suddenly goes black or keeps cutting out at a crucial moment? It's an unimaginable situation that can be quite terrifying. Especially at crime scenes or during accidents, CCTV footage can be crucial evidence. If such footage is not recorded properly or cannot be played back, it can threaten not only liability issues, but also property loss and even the safety of lives. In an era where demands for security and safety are increasing, the reliable operation of CCTV can be considered more important than any other system. If CCTV, which serves as the watchful eye for 24-hour surveillance in countless businesses and buildings such as offices, factories, stores, and homes, fails to function properly, the resulting damage can be beyond imagination. CCTV is something that anyone who has worked as a facility manager or maintenance expert has likely experienced at least once. Why do issues like screen freezing or black screen occur? Is it simply due to aging, or are there other complex factors at play? Today, we aim to address these curiosities and help you operate your CCTV system more reliably in the field by clearly detailing the top 5 causes of CCTV screen freezing and black screens that you are most likely to encounter. In addition to in-depth analysis of each cause, we will also provide specific inspection methods and practical solutions that can be applied in real situations. I sincerely hope that this valuable information helps you protect your precious facilities and assets safely and saves you unnecessary costs and time. Now, let's take a deep dive into the first cause. The first cause is the malfunction of the most basic infrastructure, cable of the CCTV system. In a CCTV system, cables are not just simple wires. They are essential pathways responsible for transmitting video signals and power akin to the veins of the system. However, if these cables are defective or have aged due to prolonged use, various serious problems can arise, often manifesting as a loss of signal or a damaged image. This can stem from low-quality cables used during installation, or cables that have become broken or damaged over time due to cuts or fraying. Even long cable runs can contribute to signal degradation, making the system less reliable. In particular, for coaxial cables commonly used in analog CCTV or LAN cables, also known as UTP cables, used in IP cameras, the internal insulator can be damaged or the insulation can wear away over time, making it easier for electrical noise to occur. This noise is the main culprit that seriously distorts the video signal, causing the screen to become unstable and flicker, or in severe cases, resulting in a black screen with no display at all. Furthermore, environmental factors such as water or dampness can cause rust and lead to inoperability, especially in outdoor systems where cables are exposed. Extreme environmental conditions affect cable performance, highlighting the importance of investing in weather-resistant hardware and enclosures to mitigate these risks. Coaxial cables are prone to internal core corrosion or poor contact at connection terminals, which can significantly reduce signal transmission efficiency. This poor contact is often a result of loose or disconnected connections, which can also be traced back to poor installation practices or simply connections that have vibrated loose over time. LAN cables are also susceptible to external impacts and improper installation, such as excessive bending or pulling. The installation environment itself, including high or low temperatures, can also damage the internal copper wire, causing it to become disconnected or the insulation to be compromised. Moreover, if the cable is too long, or if low-quality cables that do not meet specifications are used, the signal attenuation phenomenon can worsen, leading to a decline in overall performance. This is compounded by infrastructure limitations, where old or substandard cabling struggles to support high-bandwidth CCTV applications. Signal interference is another major issue related to cabling. Nearby appliances, fluorescent lighting, or inadequately shielded cables can cause interference, resulting in grainy images, distorted audio, or even completely lost signals. Electromagnetic interference, or EMI, from power lines or heavy machinery, can also significantly compromise signal quality. Noisy footage is almost always a result of electrical or radio frequency interference. Physical damage, such as mishandling during installation, rodents, chewing through cables, or damage from construction activities, can also severely impact cable integrity. Finally, termination issues, where cable connectors are improperly crimped or terminated, can result in poor signal, transmission, and intermittent connections, making the CCTV system unreliable. To inspect for these cable issues, begin with a visual inspection. Regularly check cables for wear, cuts, fraying, kinks, and any signs of damage. Look for signs of water damage or corrosion, especially on outdoor runs. Check all connections for looseness or corrosion. Beyond visual checks, testing signal strength is crucial during maintenance. Utilize cable testers to verify signal integrity and pinpoint potential faults. A CCTV test monitor can be invaluable for checking a camera's video or data connection on site. When a problem is suspected, test the camera with a known working cable to isolate if the cable is indeed the problem. Ensure that all termination points are properly crimped or secured. To address these cable-related issues, always use high-quality cables. High-grade CCTV cables, like coaxial or Cat56, allow for longer distance transmission with less signal degradation. Shielded cables are particularly effective in preventing interference. Replace any damaged components or the entire cable if necessary, rather than attempting makeshift repairs that may fail again. Shorten cable runs wherever possible to minimize signal degradation, or use signal boosters if long runs are unavoidable. Ensure all connections between the CCTV wire, DVR, and monitor are tight and secure. Use appropriate connectors, such as BNC connectors for coaxial cables and RJ45 connectors for network cables, for a secure and reliable connection. Proper grounding techniques are absolutely crucial in reducing interference by redirecting stray currents away from the signal path. Implement proper installation practices using adequate strain relief mechanisms to prevent cables from being pulled too tightly or bent sharply. Always follow manufacturer specifications on bend radii, especially for more delicate fiber optic cables. Crucially, route cables away from known sources of electromagnetic interference, such as power lines. Never run CCTV camera cables parallel to power lines. If your infrastructure is old, consider upgrading outdated cabling with higher spec cables that can support modern CCTV demands. To eliminate EMI, move cables away from potential EMI sources. Or, as mentioned, use shielded cables. Finally, regular maintenance is key. Establish a routine inspection schedule to identify worn cables, loose connections, and other issues before they develop into serious complications. Consider surge protectors and line conditioners to shield equipment from electrical noise, further protecting your cabling infrastructure and ensuring continuous operation.